Hello students, in our previous video we have discussed basic concepts in graph theory including vertices, edges, degree of vertices, adjacent vertices, self-loop, multiple edges, etc. In this video we are going to discuss about types of graphs. First is simple graph. Already we have discussed simple graph in our previous video. A graph without self-loop and parallel edges is called as simple graph. So let us draw a graph with vertices A, B, C, D and E and edges AE, AB, BC, CD, CE and EB. This graph is graph on 5 vertices and 6 edges. We have labeled this graph as G. Next concept is trivial graph. A graph with only one vertex is called as trivial graph. This is trivial graph because it has only one vertex A. Next concept is null graph. A graph with no edge is called as null graph. That means a graph with only vertices is called as null graph. If you draw a graph on P vertices and no edge, then this graph is called as NP, label as NP, and it is called as null graph on P vertices. So I am drawing here null graph on 6 vertices. So these are 6 vertices A, B, C, D, E and F. In this graph there is no edge. So this is null graph on 6 vertices and it is denoted by N6. Next concept is complete graph. A graph is said to be complete if there is an edge between any two vertices of graph G. So let us draw a graph, complete graph on 3 vertices. 3 vertices are A, B and C. Now I am drawing edge between any two vertices. That means consider a pair A, C. I have drawn edge between A and C. Now B, C and last is A, B. So we have drawn edges between any two vertices. That is pair of, you consider any pair of vertices, you will observe there is an edge between those two vertices. So this is a complete graph on 3 vertices. Next is complete graph on 4 vertices A, B, C and D. These are 4 vertices. Now I am drawing edge between all pair of vertices CD, BC, AB and AD. Now there is no edge between AC, so I am drawing edge between AC. There is no edge between BD, so I am drawing edge between BD. Now we have drawn edges between all possible pair of vertices. So this is a complete graph on 4 vertices. We will label first graph, complete graph on 3 vertices as K3. Here K represents complete graph and 3 represents number of vertices in graph G. This is K4. Now I am drawing graph, complete graph on 5 vertices and we will check a not complete graph on 5 vertices. So first I am drawing a non-complete graph on 5 vertices. For that I have drawn 5 vertices A, B, C, D and E and edges AE, ED, AD, DC, CB and BA. If you observe, there is no edge between BE, BD, CA, CE, etc. So that means we can find many pairs. If you can observe any one pair with no edge, then you can easily say that graph is not complete graph. Here we are getting more than one pair of vertices with no edge, which are, I have already told you those pairs CA, BE, BD, etc. So first graph is not complete graph on 5 vertices. Now let us draw a graph with complete graph with 5 vertices. So these are 5 vertices A, B, C, D and E. Now I am drawing edges between all possible pair of vertices. So AE, there is an edge between AE, AB, DE, CD, CB, AC, AD, EB, CE, and BD. Now you will not get any pair in second graph, any pair of vertices with no edge in second graph. So second graph is a complete graph on 5 vertices. We call this graph as K5. Now let us see connected and disconnected graph. What is connected graph? A graph is said to be connected if there is a path between any two vertices of graph G. What is path? We are going to discuss path in detail in our next videos, but for now, uh, a path is a connection between any two vertices of graph G. That means if you can go from one vertex to another vertex, then it is called as path. And a graph which is not connected is called as disconnected graph. Consider the first graph with vertices A, B, C. So if you consider vertices A and B, then you can go from A to B by edge AB. For AC, you can go from A to C by edge AC. And if you consider vertices B and C, then you can go from B to C as B to A and A to C. So B to A and A to C. If you combine these two edges, then this is a path from B to C. So first graph, this first graph is connected graph. Now I am drawing disconnected graph. So if you observe second graph, there are 4 vertices and 2 edges. Between vertices A and B, there is a path, that is edge from A to B. So you can go from A to B by that edge. But if you consider vertices A and D or A and C, then you cannot go from A to C or A to D. So this graph is disconnected graph. So first graph is G3, 2, where 3 represents number of vertices and 2 represents number of edges. Second graph is G4, 2. Similar to first graph, 4 represent number of vertices, 2 represents number of edges. In second graph G4, 2, there are 2 components. First component is combination of vertices A and B with edge AB, and second component is vertices C and D with edge CD. See another example of connected and disconnected graph. I am drawing connected graph with vertices A, B, C, D and E. So you can take any 2 vertices in this graph. You can have path if you consider vertices A and C. Then you can go from A to C as A to E, E to D or D to C, or A to B, B to E and E to D, D to C. There are 2 paths, but we should have at least one path. And we have a path from A to C. So this graph is connected graph. Similarly, from B to D, you can go from B to D as B to A to E, E to D, or B to E, E to D. So you may observe, if you consider any pair of vertices, you can find a path between these 2 vertices. So first graph is connected graph. Now I am drawing disconnected graph. These are vertices A, B, C, D, E. So this graph is disconnected graph with vertices A, B, C, D, E, F, G, H. You can have path between AB, AC or DF, DE or G and H. But if you consider a vertex A and vertex H, then there is no path between A to H. You cannot go from vertex A to vertex H. So this graph is disconnected graph. You may consider another pair of vertices, suppose B and F. There is no path between B and F. So this graph is a disconnected graph with 3 components. Next is directed graph or digraph. If there is a direction assigned with each edge of graph G, then we call that graph as directed graph. These are vertices A, B, C, D. in graph G and edges AB, AC, BD, AD. Now I am assigning direction to each edge. So this graph is called as directed graph or diagram. Again I am telling you, a graph in which every edge has a direction is called as directed graph. It is not necessary that the directed graph should be simple graph. Only condition is that every edge should have direction. So we have discussed types of graph in this video. In our next video, we are going to discuss another concepts. Thank you.